Myself, Dr. P.P. Wani from Gokhale Education Society's R.S. Support College of Engineering, Management Studies and Research, Nasik. Welcome you all on video lecture series for instrumental methods of analysis. From this video, we are concentrating on conductometric titration for measurement of conductance in case of strong acid strong base titration, weak acid strong base titration, strong acid weak base titration, and weak base and weak acid titration. For measurement of conductance, generally the conductance depends upon the mobility of the ions in the solution. Changes at various stages of this titration. This is the principle behind this conductometric titration. And major advantage of this conductometric titration is no indicator is required for this titration. You can find out the endpoint for measurement of change in the conductance of the solution. So following four different types of titration we will have to learn from this video for measurement of conductance to know the endpoint for the different types of titration. See here, strong acid strong base titration, I think we require the indicator for all these four different types of titration, but no indicator is available for weak acid weak base titration as reaction is reversible. That's why this weak acid weak base titration is not carried out by using the indicator, because no indicator till available to know the endpoint for this titration. So you will have to see one by one for that four different types of titration for measurement of conductance. Means after going through that video, you are able to learn what is this conductometric titration, how this changes in the conductance of the solution for measurement of endpoint takes place from this conductometric titration. So we will see one by one strong acid strong base titration. That is, when you consider the titration of strong acid strong base, that is HCl and NaOH is used. HCl is a strong acid and NaOH is a strong base. For measurement of endpoint for this titration, you will have to require to plot a graph of, that is, ml of base added versus conductance. And when you plot the graph of ml of base added versus titration, initially conductance is high. When you start addition of base from the burette, what happens? Conductance will go on decreasing. At certain limit, it will decreases for every addition of small quantity of base into the acid solution, and when it start increases, means that point where it start increases, I think that point is called as a end point for this titration. Why initially conductance is high? Because initially only HCl is present, and when you start addition of NaOH from the burette, what happens? Generally H plus ions are replaced by a Na plus ion, and mobility of the H plus ions is higher as compared to the mobility of the Na plus ion. When these H plus ions from the beaker are replaced by Na plus ions, what happens? That is, slow moving ions, fast moving ions are replaced by a slow moving ion. That is, H plus are replaced by Na plus. That's why conductivity goes on decreasing. But when it start increases, I think that point is called as the end point. Means after end point, only salt solution is present. When salt solution is present, I think it will start increasing. The nature of the graph for this titration is shown here. So how this reaction takes place? I think HCl plus NaOH, it forms NaCl and H2O. In ionic form, the reaction is same, H plus Cl minus plus Na plus OH minus, and it forms Na plus and Cl minus H2O. And by plotting the graph of ml of base added versus conductance, I think nature of the graph just I have described in a previous slide. And by making some calculation, that is 1 ml of 1 normal NaOH correspond to 36.5 milligram of HCl, I think you can find the normality or molarity of that acid or a base and can find out the endpoint for the titration for measurement of that concentration of HCl as well as NaOH from this titration. Second titration, I think we say that weak acid strong base titration. In case of considering that weak acid strong base titration, again you will have to fill the burette with, that is ml of base added, that is strong base, and start addition of acid from the burette. When you start addition of acid from the burette, initially conductivity is less. Initially conductivity is less, it becomes less. It becomes less and it starts slowly increasing. And when it starts slowly increasing, at certain point its abrupt change in the conductance of the solution takes place, where it start increases sharply. I think that point we say that it is the end point for this titration, but we are concentrating on why it is initially decreases and slowly increases. See here, initially when you start addition of acetic acid, initially acetic acid is present in the beaker. When you start addition of NaOH from the burette, some quantity of NaOH will react with the acetic acid and it form the sodium acetate. Means in one and the same solution, some reacted acid with NaOH, that is salt, is formed, CH3COONA, along with a strong base is added from the burette. Means in beaker some quantity of acid reacted, that is forming a sodium acetate, along with the some quantity of acid reacted is present, that is as acid is a weak and it's salt with the strong base, sodium acetate as well as acetic acid both are present in one and the same solution. I think it is expected that common ion effect will observed and decreases the conductance of the solution initially. That's why conductivity goes on decreasing initially and it start increases as soon as a more quantity of base added and acid react with to form the salt. Means we are concentrated that initial decrease is due to the presence of common ion effect, is one of the important part for this titration. So how this reaction takes place, that is CH3COH plus NaOH to form sodium acetate. In ionic form we are write that reaction with formation of CH3COO minus and Na plus ion, and the graph is plotted, ml of base added versus the conductance of the solution and nature of the graph just we have described. And by knowing that relation, 1 ml of 1 normal NaOH correspond to 60 mg of CH3COH, you can find out the concentration of acid or a base. Now come to the third titration, that is strong acid versus weak base titration. Again, when you plot a graph of, instead of base added, here acid added, the nature of graph it is start slowly increases, because when acid is added, initially base is present, the conductance is low. When you start addition of strong acid, it start increases as there is a formation of NH4Cl as a strong electrolyte. So it goes on increasing slowly, and where it start increases sharply, I think that point is called as a endpoint for this titration. See, you can plot a graph of ml of base added versus conductance, and nature of the graph is the decreases, and when it start increases, I think that point is called as a endpoint for this titration. No indicator required for measurement of endpoint of this titration, only change in the conductance of the solution. By plotting the graph, I think you can measure the endpoint for this titration, is the very important part for knowing or for measuring the concentration of acid as well as base by measurement of conductance of the solution. And now come to the reaction HCl plus NaOH, NH4OH. That is, HCl is a strong acid, NH4 is a strong weak base, and it forms NH4Cl as a salt. And ionic form of this reaction is, I think, NH4 plus and Cl minus ions are formed. We have to plot the graph of ml of acid versus ml of base versus conductance of the solution, and I think nature of the graph that we have described just now in a previous slide. And by showing the relation 1 ml of 1 normal NaOH correspond to 35 mg of NH4OH, I think you can find out the concentration of acid or a base from this relation. Now come to the last one. I think weak acid and weak base titration. I think this titration is not carried out by using the indicator because no suitable indicator is available for measuring the endpoint for this titration, but this can be carried out by using the conductance of the solution. Initially conductance is low as acid as well as base are weak. I think when addition of base from the burette, it start increases, and after a certain point when it remains constant, I think that point is called as a end point for this titration. Means when base is added into acid, conductance of the solution increases up to the end point due to the formation of electrolyte, I think ammonium acetate. Ammonium acetate formation continuously takes place in the reaction. That's why increase in the conductance of the solution. But when 100% formation of ammonium acetate will take place, then that remains constant for the conductance of the solution, and where it remains constant up to the conductance of the solution, I think that point is called as the end point for this titration. What is the reaction takes place in simple reaction everybody known, that is acetic acid plus NaOH, it forms sodium acetate. In ionic form we have write this reaction, and by plotting the graph of conductance versus ml of base added, I think nature of the graph just now I think you are known, and by knowing the thing, that is relation between 1 ml of 1 of NH4OH corresponds to 60 milligram of CH3COH, you can find out the concentration of acid or a base from this measurement of conductance of the strong acid, strong base, weak acid, weak base, strong acid, weak base, and weak acid, strong base titration by using measurement of conductance. I think from that video you can able to learn measurement of conductance for known to get the end point for the different acid base titration. So thank you for your patience listening.